Section 6. Experiencing Smart AR in VR Mode. Video 1. Look Mom, no hands, AR. In the previous sections, we have developed augmented reality apps that were based on touch user interface, where the user would tap on the screen on their device to navigate the app. However, as we hinted at the beginning of the course, the future is wearable. Hence, in this section, we will be looking at apps where the user's phone sits comfortably within the headsets on the user's head and the interaction with the content is hands-free. Over the coming 2 sections, we will create a wearable AR app allowing for modifying the virtual elements in your real surroundings. As we mentioned in section 1, there are proprietary headsets that facilitate this sort of experience, like HoloLens or Magic Leap. But this gear is expensive, so you might want to start off trying something slightly more accessible. Our proposition is to develop an AR app for your smartphone that is set within a VR framework so you can place your device inside a Google Cardboard-like headset and view the augmented world in real time without the requirement of holding your device. That has a massive advantage of being much more immersive, but it also means that your smartphone screen can no longer be used as a touch user interface. By default, the high-end headsets have handheld controllers. Some of them start to be able to recognize gestures, although that is not still 100% reliable. You can actually get a smartphone-ready VR headset that comes with a remote, like Google Daydream, and try to adapt it to the requirements of your app. In fact, such an integration is pretty straightforward. However, in this part of the course, we are taking a completely hands-free approach, where we want to minimize the dependency on the particular hardware and show you a universal approach that allows for creating apps that are very accessible. The apps presented here are interacted with using gaze. There will be a UI with buttons placed in the world space that the user will be able to activate by directing their gaze towards them for a predetermined amount of time. This could also be done using voice control, as we have seen in the previous sections. Just to remind everyone how VR is achieved, the feed from the game space camera that would be usually fed into a single viewport is fed into 2 viewports instead, one for each eye. The smartphone screen is divided into 2 and the content is pretty much the same on both halves, other than the slight offset that aims at emulating the mechanism of the operation of our eyes. While the smartphone approach has its limitations, it also comes with advantages, a very big one being the ability to switch between AR and full CGI mode. The content that is superimposed can be completely opaque, which is not the case when using proprietary AR glasses. Similarly, we have the ability to superimpose the interactive elements over the full width and height of the video from the phone camera, while the field of view available to us in HoloLens or Magic Leap is very limited in comparison to the field of view that our eyes provide us with. That results with us seeing a bounded window where the content gets displayed. In this section, we will experiment with the materials of the detected planes and creating meshes in real time that allow us to put materials on fixed surfaces that we want to have customized in our scene. But first of all, we'll be looking at emerging AR and VR frameworks. Our original focus in this course was AR Foundation, and we would like to return to it now. Next, we will proceed with implementing AR Foundation in VR mode. To avoid pitfalls of merging our build with another SDK, GVR, we will render split-screen image with the use of a shader. Once the framework is set up, it is very powerful, and for starters, you can use it to create the app that we will be presenting here. You can incorporate further elements such as particle system or image effects that can alter your vision directly. In the future, you can also use such an approach to switch between AR and VR modes if that's what your concept requires. In this introductory video, we open our eyes on stereoscopic wearable AR, allowing for hands-free interaction with digital entities in our surroundings.